This is the Optim Update. I'm Bogdan Kristey, and today's guest is Dr. Asad Tirmizi, co-founder and CEO of Trener Robotics. They work across ABB, Universal Robots, FANUC, and they've built up over 15 integration partners across Europe and the US. Asad came out of Vicarious, the robotics company that was acquired by Google. And before Trener, he helped build out the robotics and haptics program at ByteDance. This is someone who has actually built the models, not just talked about them. I first met Asad on day one at UC Berkeley Skydeck. Even back then, it was super clear to me he has something very special. And it's been so incredible to watch the journey from that first meeting now to a 32 million Series A with backing from Engine Ventures, IAG Capital, Cadence, and Nikon. So huge congrats to Asad and the whole Trener team. We get into how AI models for robotics are actually built, what happens when they hit a real factory floor, and the part nobody wants to discuss. How do you actually sell this stuff? Without further ado, here's my conversation with Dr. Asad Tirmizi. Asad, welcome in. I'm really looking forward to this. How do you feel today?
I'm feeling great, and it's always great to be in your company, Bogdan.
Thank you, sir. So here's what I want to cover today. I want to walk through with you the full life cycle of an AI model in robotics, right? So first, how models are actually built. The real version, not the pitch deck, right? Not the pitch deck version. Then how do they get deployed on the factory floor? What breaks, what works, what robot-agnostic actually means. And finally, how they get sold, right? The go-to-market, the channel strategy, what manufacturers need to see before they say yes. And then we'll close with some hot takes. Does that sound good?
Sounds great, Bogdan. Let's get into it.
Awesome. So the first topic, let's get into it, how models are built. I prepared kind of a few questions for you, but we can go off the script anytime, right? So first question for you. If someone is building a VLA for robotics today, what does the training pipeline generally look like?
Right. So first thing when you're building a robot model, it's a long process. You can look at it as a recipe, like let's say spaghetti bolognese,
I see.
Everybody knows that there are like some main components that go into this recipe, but you can always have different unique touches based on who is your audience that goes into it.
Yeah.
So when you are talking specifically about the training pipeline, so it depends on what you mean. If you mean the end-to-end training pipeline, that in comes the data and out goes the actions that are hopefully deployable. So then you're looking at a pretty big set of actions. But let's just start from where it all starts, okay, at some point around 2015, 2016, we found out that, hey, when you get data, you have this ability to create emergent behaviors out of it. So let me just put it in perspective. You have this classic sense, plan, act, loop. This is how it started for me, that okay, you have what you call classic sensor-based control. And at some point you start all right, that sensor data that comes in, if we start storing or concatenating this sensor data, there is learning that starts happening. And if learning starts happening, you can control this learning to create emergent behaviors. Now, this is a very simplistic way, but you see that there is a scaling factor applied over here, that incomes data, we can collect a lot of data, and then we can make the robots do something smart. That is a sea change from how robots have been for the last 70 years, where the human has to think, we have to structure the environment, and then, that's how robotics is done. So I think this is where the interest in robotics and the opportunity in robotics is coming to. But of course, I can go into much more details about, okay, what is this data that is coming in? And then what happens to this data, So I'll wait for your questions before I dive into that part.
So I would love to dive into that. Maybe a good question to start us off with this conversation is, what's the tell that someone has actually built models versus just read about them?
They just keep talking about data, but not about like how difficult processing that data into something useful is, because like sometimes and please, I'm not like, targeting anyone about it, but it's just uh, like people who have not built a full-fledged deployable or at least
Mm,
demonstratable VLA,
mm,
they often miss how much of that data is crap or how much effort goes into making that data into a model that is usable. Because the fact is this, like, if your timestamps are off or if your data episodes are wrong, you are putting it into essentially a black box, and
mm.
you are putting in millions of episodes. And once you get garbage in, you're certainly getting garbage out. So I think like that's the telltale sign that
Interesting.
like it's not like data comes in and like you have a VLA and, or a model that like goes out and deploys. So that's like how I check for whether somebody is actually like building it or is interested in the field. But either way, no judgment on my end on
Yeah,
whatever
yeah,
you are.
yeah. But just maybe we can educate the listeners a little bit. How does this data look and smell like? Is it in a table? How do you normalize across everything? How do you make it searchable? How do you know which data points are crap and you need to take them out? Like, how do you approach these things?
Yeah. Uh, so smell that I can't tell, but how it looks like that I can tell. Uh, okay, so there's a lot of things to unpack over here. Like let's like try to make it simple yet like deep enough that like it covers a broad range of audience.
Yep.
The first thing is raw robot data collection. So then you're looking at basically time steps, that include observations, could be camera images, depth images, robot joint position, robot joint velocities, joint torques, like based on like, let's say, typically what you do is like you have like an observation part of the data and then the action part of the data. And I'll like connect this
Mm,
at some point, but like this is the like raw pipeline. So you'll have joint torques, joint position deltas that goes into the action head, and then you have the observation part where typically it's like encoder positions, and then the camera images that like go into that part. So that's the raw
mm,
data stream that you are looking at. And then like the next part that comes in then is the data set construction. And this is the part where, like which is hard. And frankly speaking, in my opinion, uh, if this thing takes off, then
yep.
this whole data set construction, that you can like create like a company out of it, because when we started doing it, like aligning timestamps or interpolating missing frames or normalizing joint coordinates or
Mm,
removing corrupted runs. I mean, please look at it like, you're looking at a huge, huge amount of data because you have teleoperator data, you have like open source data that you like, got from somewhere. Then you have like simulated data. And now all of that has to converge into,
mm,
you can
mm.
call as, I don't know, training sample, that like make it into a observation and then a associated action. Does that make sense? So it's like a lot of
Yep.
data comes in. You have to like make that into usable data set, and
Yep.
then this data set becomes into a set of observation and actions. And that is where, like then the GPU part comes in so that like you can start like making embeddings out of it.
Yeah, yeah, that's super interesting. That kind of leads me towards my next topic here, how are models deployed, right? So we've been talking a lot in the robotics space about skills. So I'm curious, how would you define a skill in practice? Like, for example, if I'm a shop floor operator, what changes for me personally?
Right. So I think like if you are a top floor operator, basically, you would previously buy a robot and then you would go to somebody who knows how to operate robots before, like, that robot is of any use to you,
Yeah. Yeah.
uh,
Yeah.
and then the whole idea is this, like, with all this data set, and like, I mean, I didn't go very deep into it because there is a part that, like, what I described as a training pipeline is essentially very slow. So there is still a lot of work that needs to be put in so that you can make it fast enough. Uh,
Mm,
but once that is done and done correctly, and now you go to a machine shop, what
mm,
comes out as an advantage is this, that now suddenly a skill has intrinsic knowledge on how, for example, CNC machining is done. So if
mm,
you as a operator do not know what is going on, the model knows what is going on because we trained it on all the visuals of
mm,
machining, all
mm,
the actions of machining, haptics of machining, language of machining. Because for a average Joe, if I was to say, like, let's clamp boost device, what does it mean? But you need to know what does that mean if you have to, like, deploy a robot to do that. So in my opinion, the robot skill is that particular unit of software that goes in and brings the intrinsic knowledge of the task, the domain expertise of the task, and then the ability to generalize no matter
mm.
what happens in this task, like if there is
Yeah.
cylinders or there are clamps or machines. So that's how I look at it. So it's a very, I would say, successful business model.
Got it. Got it. So maybe a good follow up here is, where does abstraction win and where does it leak?
Uh, I think, like, abstraction, if done right, always will win.
Uh huh.
Uh, um, uh, Except when it's not done right. So, like,
I see.
like that's just like how it is. Because there are things that if you not abstracted them well, you are just
Yeah.
like bound to, like, create like customer dissatisfaction. Now, it is also true that there are things that do not abstract very well. So at least in our company, the business model that we have is this, that we partner with system integrators. They are a
Mm,
very essential component of our go to market. Because the idea is just like, things that can be abstracted away, we abstract them away and we do them well. But then we are
mm,
very open about things that cannot be abstracted and in a way are a domain knowledge. And it creates like this perfect mix where system integrators and OEM bring what they are best at when it comes to hardware or fine manipulations,
mm.
but then the overall setup that is then abstracted away to the AI model. So at least for now, we have, like, seen good success with that approach.
Got it. And what's your experience? How has your experience been like with high mix manufacturing, right? How does that, are there any breaks in traditional automation for that? And any thoughts on that topic at all?
Um, I think, like, Hymix is a precursor to going towards unstructured and semi-structured environment.
Mm-hmm.
My opinion on this is that, like, if you are going into robotics today to, like, make robots better at just repeatability, then you're solving kind of a solved problem.
Yeah.
Uh, the real price over here is not this, that the robots can do CNC machining. They are a good entry point, but the real price here is that robots can do much more than what they have been traditionally doing. And you can start, like, from a traditional space, but you can expand, like, very much. So, high mix is typically something that robots were not good at. So that's like a natural point for AI robotic companies to
Mm-hmm.
start their journey with. But then this journey is limitless, in my opinion, because there is just so much, like,
Mm-hmm.
automation labor needs that if you get this flywheel going, it's almost never ending.
Got it. Got it. Well, that kind of takes us into the factory reality, right? In your opinion, where the systems actually fail, like what is surprising you? What's your experience been like there?
Right. So a factory is not just a robot. That's number one. A robot is a
Mm,
very small part of the big factory. And frankly speaking, those who are working in factories, they do not look at a single unit that is doing a part of the job. They look at like the overall production, over there, a lot of things that look like really great in demos, they are just like either useless or nobody cares about them. What they care about is predictability, determinism, and this robot will be able to do the task in this amount of time, so making sure, like, I think like when it comes to factory, the simple answer is this, that if you do not have reliability, you do not have anything, so it is much better to like keep yourself feature light so that you can do the job at hand rather than have super feature rich product. Half of that features are never used, and then like digging yourself a hole by basically
Yeah.
stopping the entire production floor.
I'm curious, how do you catch drift and silent failures in production? How do you think about that?
Right. So I mean, there is no doubt about it that like your monitoring or how you monitor your system is extremely important, and this is actually a very difficult part of the job because factories, they have their own IT OT systems. So you have to
That's
be
interesting.
very mindful about that because you can't walk into Mitsubishi or Siemens and tell them like, hey, I come with like something fancy, but you have to like take your whole IT system down. It's not going to happen. So typically how it happens is this, that like you need to have like a baseline system for monitoring, for QA testing, for
Yeah, you got
essentially
to
like,
make some friends first, right? Before you.
right. I
The-
mean, but like if you are like getting into an enterprise contract where the firewalls around IT, OT are really severe. So then you need to have like a local server system, where these things can be handled and then some special arrangement to get this to you. Because if you don't have visibility, you will for sure lose that client. Because these things will happen. Sensor drifts will happen. Like grippers will break a joint, and that is at the end either your responsibility or your
Mm,
partner's responsibility. How we deal with it is just that integrators, they have been like doing this job for a very very long time, so
uh-huh.
there is a lot of like day to day maintenance that no matter how awesome your AI is, that will still be required. And you need
Mm.
to look at the ecosystem and like have friends in the ecosystem all the way from the buyers to your partners to basically give a good service level.
Got it. Well, on that line of thinking, in your view, what's the definition of reliable enough?
Yeah, so that's something you have to very carefully define for the domain of applications that you are
Mm.
going after, I can give you an example
Yeah.
from one of the domains that we have, which is the machining models that we are deploying. So basically the mean time between failure, part changeover time, these are like extremely important things, and calculating that realistically, because at the end, like once it's a failure, it doesn't work like this, that like, hey, my model didn't fail, it's actually the PLC that like I don't know, had a failure. It's also system verification around like, okay, what kind of system have I put together and how much of these systems are natively supported by my
Mm-hmm.
model. So that's like, some really key metrics, but then there are like some side metrics as well on like, okay, what is the time to deploy? What is the time before we pass the factory acceptance test? So those are
Yeah.
more like operational checks that we have to do. But after that, we get a comprehensive picture. And most important for the business side of the things is what is the ROI for the end user? Because that is something that you will use over and over again. And I think with these base metrics, you can
Hmm.
very easily calculate what is the ROI. And once you have that, you have then a very good like marketing material, also a very good understanding of whether you're pricing yourself correctly or not.
Yeah, on the topic of marketing material and pitch decks, I always find it interesting to compare the reality between the shop floor and like the pitch deck metrics, right? So what matters in evaluation the most, do you think?
You mean the evaluation of the pitch deck? I didn't like understand the question fully. Can you repeat it?
Evaluation of the technology and when you're talking about deployments, when you're talking about hitting your metrics, you have the pitch deck numbers, and then you have the shop floor numbers. So I'm just curious if how do you think of evaluation in general about your day-to-day business, what's actually happening on the floor, and then how do you communicate that in marketing materials and so forth?
Right. So I think like this is where, I mean, at least I'm very clear about it, that inflating numbers or showing a better version of your product basically hurts you in the long run. Typically, companies that adopt your solution, they are those companies that have a forward-looking outlook. And
Yeah,
at least the customers that we have seen that there is a lot of they're passionate about it. Like, and I'm not talking about just the big customers, I'm talking about the small customers. It's really
yeah.
fascinating for them to have a robot that they are talking to, that is seeing around, that is changing parts, whose
Mm-hmm.
movements in a way remind them of the movements of a fellow human. Uh,
Yeah,
so personally, or maybe, I'm just lucky at this point, at this scale, that
yeah,
we have investors and we have customers
yeah.
who really expect that, like, the numbers are what we are seeing is what we are marketing. And that's exactly what we are doing. So at least in our case, we are not, let's say, trying
Yep,
to like paint a rosier picture than
yep,
really
yep,
is.
yep, yep. Yeah, I wonder, kind of what's the most misunderstood thing today about deploying AI in factories, in your opinion?
AI models, as we typically know them, are probabilistic systems.
Uh,
It's a probabilistic output that comes out, and robots are systems that are or should be deterministic systems, especially like in factory settings. So this is a very important, I think, distinctions that for model builders need to be clear, that once
uh,
you put in something that is fundamentally probabilistic in nature, uh, you are creating issues for yourself. I mean, this is an architectural question for most CPOs or product executives, that how much do they want to invest in the layer that at least ensures that safety is deterministic, because otherwise, I mean, you're playing with somebody's life.
yeah.
But then there are also, deterministic actions that you can take or higher level parts of your stack that will make sure that, and frankly speaking, like in our company, at least, like this has been the main part of our research for the last 14 years, because we always knew that there is a learning or emergent behaviors that are
Uh,
coming, but how do you make them factory ready or workshop ready? And like, how do you like change something fundamentally probabilistic into something that at least have some critical functionalities that are deterministic?
mhm. So if you had to name one bottleneck to scaling real world robotics, like what would that be?
I'm like thinking because there are many bottlenecks. So I'm just like, trying to, uh,
We can do
so
top three.
I think like the number one bottleneck is the cross embodiment problem,
I
because
see.
models, they need to be, it's just like, if anybody says right now that like, cross embodiment does not degrade your model performance, that's a lie. I mean, I just stand
I
on
see.
it like very, very strongly, because I've been doing this for a while, and this is a really important problem.
Yeah.
I think like there are good signs toward it that like this will be solved. But this is fundamentally a thing that is unsolved.
Mhm.
So there are ways around it that at least like, like for example, we have to fine tune our models to the robot brands that we support. We have to like, do this additional training. You can look at it like as a baseline training, and then there is a training for the FANUC robot, and then there's a training for the UR robot,
Mm.
until they come to a point where uh, they are behaving, at acceptable levels. So I think like that is one. The other one that I was like having this conversation in my head, like should I say this as the fundamental problem or the other one? The other one I think like is often repeated, which is the
Mm.
data problem. That
Yep.
data is indeed uh, something that is critical for these models. They feed on it, but it is extremely difficult and expensive to collect that data. And like when I say collecting that data, it's not that like collecting data is difficult. Collecting the right data, that is the challenge. So
Mm.
honestly speaking, when companies come and say like, hey, I have like this data foundry somewhere in XYZ country and they can give you like 5,000 episodes. I don't know how like you do the quality control over what went into your model, because once they are in the black box, finding out what went wrong could be like just like 5 episodes that are just like making a million good episodes redundant. That's just
Mm.
the truth of like how this works. Um,
Interesting.
so yeah, you have to be careful about it. So these two are the biggest issues
Got
to
it.
scale, in my opinion.
Yeah,
I mean,
those
there
are good.
is a third one as well, which is of course
Go for it.
uh, the like we as roboticists, we have never had a chip that is made for robotics. We have always
Mm.
worked with something that was fundamentally built for some other type of computation that then got accepted as the de facto compute for robotics. For the last 30, 40 years, it has been like CPUs. Those who have been in this business for a while, they know this, that I think until like 5, 6 years ago, there was still Windows XP on a lot of
Yeah,
like
yeah, 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 yeah. Absolutely.
major like controllers. And frankly speaking, like whenever you have like some intelligent behavior that has to like run on a robot, like this compute is like a bottleneck. And this is like, even today, this is very correct, because fundamentally we are working on NVIDIA GPUs, and
Mm.
they are general purpose GPUs, which are not built for robotics, like, like the industrial IOs, the safety certifications, the real time control aspect. There is just a lot lacking over there. So I think like getting the right compute chip that can power this AI revolution, this is very important. And I don't see it coming from NVIDIA, because I fundamentally think that their business model is, let's have general purpose GPUs, the
Mm.
same on crypto, same use for data centers, and same for the robots. And I think like we face, and I think a lot of other robotic companies will also agree that they face a lot of problems with the standard chips like Jetson Orin or Jetson Core right now. And this is something that we need to change as well.
Is the issue around, cost, or are they just not as efficient as they could
Right.
be?
So it's both, because I mean, cost wise as well, like,
Mm.
you're like talking about like anywhere between 4,000 to $7,000, like based on
Mm.
which flavor of these GPUs you're looking for.
Mm.
Um, and this is like quite a big cost. Like, when you think about like, hey, every deployment that we do now has to get like this compute box. I think like it's too early in the AI game to have such huge margins on these chips, because we should like really try to create a market and then like put in the margins over here. So I would be very happy if there was a $500 chip that we can just add and run the model on.
Yep.
That's number one. But number two for me is also the performance point of view, like, the safety certifications that like you have, or the industrial IOs, or the real time control aspect, especially,
Yep.
like how like the shared memories work. So there is just a lot left to be desired over there. And I wish
Got
like
it.
somebody would solve that.
All right. Well, as an investor, I will bookmark that in my head and go out there and look for some founders doing this.
Yeah, please do. And like if you do find somebody, like ask them to order like 100 like chips for me already in advance if they're doing good.
All right. They'll have their first PO.
That's the first PO. That's ready to go.
Okay, so talking about POs, let's move into the most what I would consider the most fun conversation topic here, which is how models are sold, right? So I think the go-to-market question doesn't get enough airtime in robotics conversations, right? So building a great model is one thing, figuring out who buys it, through what channel, at what price. It's kind of a completely different challenge, right? So maybe one question here I can start us off with is the fact that you've chosen to go through integrators and OEMs rather than direct. So the question is why? What does that unlock for you guys?
System integrators are just better than us in integrating systems. Like it's just like the truth. Like I can just tell you this, that this is not just true about us. This is true about, dare I say, 99% of Silicon Valley companies. Like what is our strength? Our strength is software. Our strength is AI, you know? So we build the model. This model is working. It depends on like what you want to make it work for. Some want to make it work for everything in the world, then just release it. I think like that's a pitch of like some of the hyper scaled or hyper, whatever you call hyper razors.
Yep, yep, yep.
For us, we create like, you know, these small models that are edge deployable and are like really good at like, you know, a certain domain of tasks. So let's say now we created a machining model. Now we know that this is a great model. Last year, that model won the Machine Tool Innovation Award. So we know that like, it is doing great machining and machine tending.
Mhm,
But now what do we do? Like, should we like go and now start deploying it ourselves? That's where like, you know, you have to like look into the margins. Like the software part, there is like 83% margin on
mm,
deployments. At least for us, it is like somewhere around 17 to 18% margin. And
mm,
the margin is not the only thing. We're just not as good as a system integrator, you know, who is
mm,
deploying machine tending for a very long time. This also goes for hardware as well.
mm,
Like a
mm,
lot of like Silicon Valley companies get inspired by Apple and others, and they say like, hey, let's like we need to like have the full stack and all power to them. But I personally feel this that can I compete with FANUC on hardware,
mhm,
ABB with hardware? No way. I mean, they are great robots. They are amazing. I mean, I love those robots. I've worked them for a long time. I don't want to recreate things or be or try to like get good at things that there are already players in the market that are good at. Our models empower them.
mm,
That's what I'm after. Like, you know, empower them so that like combined we can take one of the greatest solution ever in robotics that solves a real problem. And what is the real problem? The real problem is this, that there are so many dull, dirty, and dangerous jobs in the world that humans should not be doing. You know,
mm,
humans can still have this job, but the labor part of that job should be done by a robot. Uh, we as a species are getting on average older than we should be, right? I mean, some might argue that we were never built to like, you know, last like more than 60 years, you know, and now like I don't know, there are countries where average population is gonna hit 60 years. So to be able to have like the quality of life that we have,
mm.
robots are necessary. That's the problem we are solving. And I mean, this is gonna be the biggest market that there is. Labor is the biggest market, you know. So there are
Yep,
no shortcuts to it. And there
yep.
is a room for a lot of like players in it. But if you try to take over everything too early, you're either going to kill yourself or you're going to stop the market from developing.
I see. Yeah. You touched upon this a little bit, but we talked about CNC tending.
Mm.
Um, I'm curious, what's the expansion playbook after that? Like, what's the plan? What are the things that you want to look into?
Right. So when we started, we were like, okay, you know, we have like this great software. Took us 14 years to develop. It's working very nice. Where do we take that software? I mean, the cool part would have been to take it to a humanoid which is jumping around and like falling off the roofs and all that stuff, you know, like that is cool to see. But we were also, I personally believe this, that there is such a huge market over here
Mm,
that there is a part of me that does not want to rely on venture dollars to make it into a business. I want to like really like, bring it to a point where I can see it as a business that grows on its own revenue. There is a data flywheel and revenue flywheel that I can see clearly as a day, and I just want to reach it as fast as possible. So if you have like this mindset, you can go into a market which is a market where robots are not deployed because there are a lack of regulations. There are many issues that you will get into deploying. You also cannot go on robots, where robots do not have a big market, like, humanoids or like mobile robots, they have a smaller market. So CNC was like this perfect, like, thing where you had like a huge market, a lot of robots do this. They don't do it well. Still, they get sold. So if you do it well, you have a pretty good like market share. And then when you deploy in CNC, what you are training is not a CNC model. What you are training are atomic skills that combine to make CNC. So it's like, how do you pick a part? How do you place a part? How do you insert something? This is where the data is going, the atomic skills. And then this data can be combined to make more and more skills. So we have a very, very ambitious roadmap of around 20 skills that we want to put out, which are typically skills that are needed in unstructured environments. And after that, we want to like, open up our, like there are only as many skills as we can train, so we have like some very big ambitions on like how we open up what we are doing to make skills, that we do not have an idea about. Like, for example, there is a founder that came to me and he's like, hey, I got some venture dollars a while ago to pick apples, but like picking apples is very hard, so just like you can train your machine tending skill, can't I like train an apple picking skill and put it on my robot? And I was like, okay, there's no world in which I would know anything about apple picking. But if I can enable this person with our tools and our, how do you say, infrastructure to pick apples, that's great. That's a great business model. That's great for the world. Maybe apples will be cheaper. So you will
Yeah.
get like cheaper apple juice, So,
Interesting.
yeah, so we have like a very ambitious, aggressive plan to go to more semi-structured manufacturing task and then just basically keep on increasing to
Yep.
wherever there is a market for a skill.
Yeah. So you said 20 skills on the roadmap. What are 3 or 4 of your favorites, just so we get a little bit of color here?
Yeah, so inspection is like a really huge one for us. One of our investors is Nikon. They have like incredible vision systems for inspection, and they have a ton of data. So it was just like I saw that, and I could just like clearly make a connection between like, oh my god, like this we can make inspection skills that like never have existed before. Then there are like things that we have been doing for a long time, but like we can do much better right now. So bin picking in harsh lighting environments, especially when you're dealing with metallic pieces. Um, Very interested in like, also one of our investors is Cadence, because of whom we have access to like really amazing physics models. So we could like see that like we can put really amazing physics into a lot of like, things that we are simulating. So you can see stuff like not just pick and pack, but being able to pack things that were not possible with robots before, like squishy toys or flexible material. So I think it's like one of those things that like if you get into this frame of mind and you get like the basic recipe right, it's like I'm walking and I'm seeing things that like robots can do and a human should not be doing, which will be better for the human and the robot. So let's just say that there are some really interesting things that are on the roadmap. And then there are some really hard things as well that cannot be solved today, but we are very passionate about solving them. So, for example, assembly, that's a very hard one, because you simply do not have the dexterity right now, to do like the kind of assembly that you need to do. So you can do like bits and pieces, but to make a model that like passes our criteria to do proper assembly, it doesn't exist, so there is what the point I'm trying to make is that there is a very intricate connection between what you can train and what are the hardware capabilities on how you actuate. So that's something to also keep in mind.
That's interesting. Um, something that I always think about is, what does a manufacturer actually need to see before they say yes to a project?
That is, I mean, our experience has been mixed on this
Yeah,
as well.
yeah, yeah.
In the early days when we had trying to get that first customer, like that was, I mean, that startup is the hardest, especially when it comes to like an upfront capex that they have to deploy. Then it is something that is affecting their production. It's a very hard thing when they ask like,
Uh,
hey, how many have you deployed, and do you have like any data, anybody we can call that can like say that this thing works. So that was like really hard, but like once you have like those case stories, once you have like those metrics as we were talking earlier about,
yeah.
once you have like also when you like see some success, so you also invest into confidence building measures. How can
Mm,
I invite my customer to our premises and show them this thing in action? How can I like put that machinist on the system and like make them ask their boss to buy this, So
uh-huh.
I think like it's one of those things that success begets success. So I was just looking at it like it's for the first time, it's the first quarter where we have inbounds that are converting into sales for our system integrators, so as you know, like we don't do direct like deployments, we go through system integrators. But
Yeah.
it's quite funny to like see that like in France our system integrators are getting inbound, or in Portugal. I think like as a founder it is always fascinating to see that like, hey, that this thing is like wanted, and that means much more than like any other thing.
Well, after 14 years of building this software, you're an overnight success, man. Congrats.
I'm calling it overnight, like it's like a tough one, but like I don't want to like also like just say that as if everything is solved. There is literally a mountain in front of us that we have to climb,
Mm,
because if we and other companies in this space, we play our cards right and we develop this technology right, I can just tell you that this will have like very strong effect on the world economy, and that's fascinating. I think that's why you become founders, right? Like
yep.
have an impact.
Yep. You see something that you think you can do, and you can't stop yourself. You have to go over there and
Yeah,
build it.
yeah. I mean, to be honest, like I was awake all night last night. I haven't like slept, so I have like a brain fog right now. Because I was just like, I mean, the same things that we are discussing. I was like just so engrossed in a problem that I worked till 2 a.m. and then I couldn't sleep because I was still thinking about it. So at 4 a.m., I just gave up that I'm going to sleep. And I was thinking about you because I was like, okay, how would I give a podcast with such big brain fog? So I hope that I did an okay job.
You're doing great. Actually, we only have a few things left. We're right on time, so I think you're doing great. But let's keep going with the fun part of our conversation, right? I'm curious, how can I get a couple of hot takes from you, right? So maybe, maybe I can ask a few questions that you can tell me
Yeah, yeah, sure.
an answer kind of a little bit, quick. Don't think about it too long, and just be honest, and jump right in it, right? So maybe the first question here is, what do you think will look obvious in 5 years that sounds non-obvious today?
Uh, Today we do functional programming. I think in 5 years we'll be doing declarative programming across robots, or in easy terms, today we code or program robots. In 5 years, I think we will declare our intentions to the robot. And
Mm,
even these intentions, they will be partially declared, and the robot will be able to fill the rest of the declarations.
got it. All right. Any one piece of advice for a robotics founder starting today?
don't underestimate the last 10%. Like,
Yeah.
it's like, it's like one of those things where you feel as if, like this whole field is made to suck you in as if like, oh my God, like I got it right, because look at it, like, the amount of data that I have and look at the performance that I have. And like, it just gives you this like, oh, I might be doing something that nobody else is doing, only to find out like the diminishing returns as you go into the 70, 80%. And the last 10%, man, that just makes you cry, because now you have like this huge data set and there is a black box and, you just, yeah. So I think like the real challenges, they appear on the last 10%, and the
Mm,
more later in the percentage points you go, um, the
I see.
more bigger the challenges become.
So this may already be the answer to the next question, but I'm gonna ask it anyway. Maybe it's different. What do most people get wrong about robotics right now?
I think like this is kind of like I already answered this like in the
Yes.
previous one, that
Yes.
it's my CTO and co-founder Lars puts it in a very like nice way, that a 90% result in academia is a groundbreaking result. A 99% result is a great demonstrator, but it is still not something that you can deploy. It's only when you go to 99.99, that you have something that you can effectively scale. And one of the fears that I have for founders and for in general robotic community is this, that at like 90%, the story becomes very convincing. It just looks like, oh my God, like, this is gonna really work. But there are like so many moving pieces in this story,
Uh-huh.
that to get it to 99.9% consistently and scaling, this is like hard. So yeah, so like my let's say advice, if I'm like qualified to like give that, I don't think so I am, but would be this, that the grand in the grand scheme of things, getting things right, even if at like small scale, serves you much better than going out to like something too big that you just
Mm.
cannot bite, because you can like have a valuation of $39 billion, but you will be solving like same problems that like like you're just like solving a much bigger set of problems, and the impact is still like very limited because you're stuck on something very small.
Yeah, well, having seen you from your early days at Berkeley Skydeck, from before anybody ever wrote you a check to now a $32 million successful Series A with amazing investors and people, it's been fascinating to watch your journey. So thank you so much for still answering my texts after you're becoming quite famous in the robotics community.
Really?
So
Okay.
really,
That's news
really
to me as
appreciate
well.
it.
Now, Bogdan, even from the early days, you've been like a big supporter for not just me, my company, but I've also seen this, that like, you have done this across the board for many, many in the robotics community. So deeply from my heart, I'm very thankful to you for the support to me and all the others. And I hope like, this talk that we had like might give some new ideas, some new like, takes on what needs to be done and who can do it better than even you and I, So
Hell
really
yeah.
very thankful to be on this, and hopefully we can continue this journey of innovation.
Absolutely. Well, thank you so much for your time today, Asad. Really appreciate it. Thanks for the conversation.
Thank you very much.